Same stuff we didn't finish your notes yesterday. Addition to 7.6, and we didn't do this yesterday. If I remember right, we did the ACT stuff, right? Okay, so we didn't do those. So you're supposed to expand these logarithms. You're supposed to expand them. On your formula quiz, you've got, this is a little bit different than what's in your notes, but you've got log of A times B times C in your form quiz. I know you do. How do you break apart a logarithm that contains 3 terms?
Addition.
Through addition. You write out 3 logarithms. That's what you do. Now this guy that you're given, log base 6 of 9x squared, has how many pieces? 2. 9 times. So when you break it apart, how many distinct logarithms will you have?
2.
Of 2 of them. You have a log base 6 containing a 9. You're going to add in a log base 6 containing an x squared. It's called expansion. Seems kind of funny to do. That's how logarithms work. Well, this one's not done. It says express powers as factors. I know that seems funny, but you've got a property. The property on that is log a to the r. Where's the r go?
Oh, and
It goes in front. You see a power,
2 log.
put it right there in front. Log base 6 of 9 plus 2 log base 6 of x. It's kind of funny to do things like that. That's how logarithms work. It's not a hard thing to do either. You just got to know the property. You break apart multiplication of what? Addition. How do you break apart division? Subtraction. That's really all there is to it. This one's probably not written right. It's supposed to be a better looking fraction. I'm going to type it out. It's 8 over 3 y to the half. What's it supposed to look like? How many logarithms do we have on that one?
2.
Nope.
Sorry. You won't have 2.
How many pieces is there?
1, 2. I mean, there's also 3.
3.
3. But I thought it was all on the bottom.
I understand that, but this has multiplication sign inside.
Okay, so
No,
you still subtract.
you still subtract. On your form quiz, I'll just keep bringing that whole thing up. On your form quiz, you have log AB over CD. That's a log A plus a log B. It's a log. You might remember the rest of it? Minus. That's the form. It's actually trying to tell you something too. In that form, A and B are in the numerator.
So they add.
So they're added.
And bottom subtract.
The bottom subtract. Well, I'll write that down. If it's in the numerator, it's positive. If it's in the denominator, it's negative. If it's in the numerator, it's positive. If it's in the denominator, it's negative.
Wait, negative or subtract?
Negative. Subtraction symbol. If you talk about like 1 minus 2, you're saying subtraction. But if you say 1 plus a negative 2, you're saying negative, right? So again, I hope you realize this thing had 3 distinct parts. It's going to be 3 natural logs. What's in the first one? 8. What's in the second one?
3.
What's in the last one?
1.5.
Not worry about signs. The 8 was in the numerator, positive or negative?
Positive.
That 3 was in the denominator, positive or negative.
Negative.
Y was in the denominator, positive or negative. What's missing?
Bring the 1/2 to the front.
This says bring that 1/2 to the front. All exponents can be moved to the front. It's property of how logarithms work. So those two stay the same. That's it. And deep down inside, you probably want to say natural log 8 minus natural log 3 is natural log 5. It doesn't work that way. All right. Anybody any questions on that?
No.
Twice. Now to see. How many pieces inside that logarithm? 3. Nope. Or there's an understood multiplication symbol there. There's an understood multiplication symbol right there. 4 things. By the way, this is, I typed this out. I didn't have an editor. It's supposed to look like that. All of 4 West is supposed to be like that. So once you figure out there's 4 pieces, you write down 4 logarithms. Make that one a little bigger. Is everybody okay with identifying pieces except for Chris? He's like over 2 right now.
At least
What goes in the first logarithm? 4. You're not LJ. One LJ. LJ, what goes in the second one? Do you happen to know the exponent? What's the exponent for the square root function? Okay, let's go back over x to the p over r. You talk about the square root of something. What's its understood exponent? How about the thing inside? What's its understood exponent? 1. Talk about the square root of something. You're thinking about this notation that I taught you a while back. Power over root. Square root is the exponent what? 1/2. So that was a square root function, LJ. What's the exponent? 1/2. You got to have that exponent there because where are exponents supposed to go? The front. All right, third thing, what you got, Micah? 4. Last thing, what you got, Jillian? Y squared. Now let's worry about signs. Which ones are positive? First 2. Nice thing about doing it this way, you just write it out in order. Which ones are negative? Because they were in the denominator. Really that simple. All you gotta do is worry about exponents. I see an exponent of 1/2. Where does it belong, Eva? In the front. Natural log of 4 plus 1/2 the natural log of 6x plus 3. Take away a natural log of 4. And I'm at the last one and I see a square. Where's that 2 belong, Greg? I'm looking at this guy right here. Where's that little 2 belong? In front. Minus 2 natural logs of y. What you guys do, D?
would you be able to take out the ln4 minus ln4? Okay.
Should have caught that right here, shouldn't we? Yeah, of course you did. Should have noticed that right from the start, didn't? I'm glad you saw it. Anyways, you guys do D. Actually, put the pencil to the paper there, Jordan. Let me see what you got. Like 95% correct. I don't expect anybody to get D correct. I might be surprised.
9 squared.
9x squared is 2 things, though. 9x squared is 9 times.
It's always.
By the way, D is not a natural log, it's a log of base 3. Not a natural log on D, it's a log of base 3, it's not an N. Log. Hey, you go, Brandon, at all.
Oh my gosh. Okay, let's see how many you get.
You would have got it back, no, you were wrong.
I was thinking about it a while ago, but I wasn't thinking. I didn't think you'd have to do that.
Which way was that?
No more than that.
Log of it. You not come in on time?
No.
I don't want to burn a whole lot more time on this, so I'm going to jump down to the typical answer. If you answer that, congratulations, you just missed a question on your pre-calc class or your enrollment class next year on the test. If that was your answer, you missed it. Go ahead and shut your mouth. You missed it when I told you you were wrong. On the homework you guys just turned in on the front of the page, you were asked to write a verbal description of what a logarithm is asking. Weren't you? Don't cuss me.
I do.
You're the one who forgot it.
I do.
What's the first thing asking?
What is, what power of 3 is 9?
What power of 3 creates a 9? You know what's asking? If you did the homework, that is a 2. 3 squared generates a 9. Just pointing something out to you. I've watched kids and stuff like this forever. Just point it out to you. I told you, whenever I see a logarithm, the first thing I do is I put in the words in my head. That one's answerable. If I look at the second one, 2 log base 3 of x, I have no idea what power of 3 creates an x, so I can't do it. Does that make any sense? But if there's something I can do, I do it. All right. That was expansion. What's the opposite of expansion? Contraction. Condensing. Tell me you're a nurse without telling me you're a nurse. Contraction would be the opposite of dilation, I guess, right? Condense the expression to a single logarithm. So, after expansion must come condensing. What's the problem with A?
Broken up.
In order to condense logarithm, they all have to be what?
A logarithm.
Logarithms. In the expansions you were just doing, with the exception of that last one, even then, the last one you actually wrote up 4 logarithms, right? And then you evaluate a piece. In order to put something back together, everything has to be a logarithm. 3 ain't a logarithm, but it can be. I jumped to condense the expression into a single logarithm. All right, anybody know what log base b of b is asking? on your form quiz too. What is log base b to b asked?
What power B is B?
What power of b creates a b? What's the answer to that? 1. I noticed these were log bases of 5. So I would be asking myself, log base 5 of what would be a 1?
0.
5. Because that says what power of 5 creates a 5. The answer, that's 1. I need a 3, don't I? So I just throw a 3 in front of that thing. 3 log bases of 5 would be 3 times 1, or 3. The number 3 is 3 log base 5 of 5. Because what is log base 5 of 5 saying? It's 1. Now everything's a logarithm. Now you can do it convincing. Not that hard. You're still, wow, you're like, your mind is blown. You even know that formula. You've been getting right at the form quiz, you just know it's 1, right?
Oh, that's not what I was confused about.
Anyway, she's a logarithm now. Everything's a logarithm. And this is opposite of what you were just doing. So instead of breaking apart a fraction, put the fraction together. Logarithm that contains x squared plus 4, is that logarithm positive or negative? Where does x squared plus 4 belong? Numerator. That's simple. What do you think you should do with that 2 and that 3 before you actually start putting them in? Make them exponents again. If you go back and look what we did, that was usually the last thing we did in the process, was move those exponents out front. We're doing this backwards, kids. They got to become exponents again before you can throw them back into the logarithm. So now you've got that log base 5 of all of 4x squared. Where does all of 4x squared go? On the bottom, because that's a negative logarithm. Then you got that log base 5 over 5 cubed. That log positive or negative? Where's the 5 cubed go? Numerator. I don't know that I would stop right here. Kids do so. I haven't graded, but only been about 10 of those taking tests. You kids do the dumbest things. You leave in a set of parentheses 1 plus 2.5. Why do you do that? What is 1 plus 2.5? Why don't you write that down? You do things like 1 minus 0.63, you leave it in a set of parentheses. Are you incapable of doing 100 minus 63 and thinking it's 37, moving the decimal 2 places? Apparently you are. I don't know why you kids do that stuff. Don't stop. Do what you can do. You know what 5 cubed is, don't you? What is it? 125. I can't tell you when you take a state test how they're going to represent an answer, but you need to be comfortable with doing more work than just the bare minimum. What do you get when you square a 4x? 16x to the second. I do not think that they would actually put 125 and x squared plus 4 together. They might, but I'd be very surprised if they do, because that would make it harder to break apart. That's probably where the state would stop. Any questions on that one? Let's move on to C. Jordan, where's that half go? I said it's B, sorry. Jordan says that half is now an exponent. It is a square root. Olivia, where's that 3 go? Exponent. Now, while you could answer what log base 4 16 is, it's 2, should you?
Not for this.
Not for this, because you want to say logarithm, don't you? If it's not a logarithm, you can't condense. So just leave it the way it is. Now you're ready. one big log base 4. Got 3 things in it. What's something in the numerator?
5x to the 1/2.
5x to the 1/2. What else is in it?
2 to the 3.
Oh, I forgot the 3, didn't I? Maybe you told me I forgot to write down 2 cubed. By the way, I'm putting them up top because they are what?
They're
Positive. Where's the 16 go? On the bottom. If I was a betting man, I think they would rewrite 5x to half. Square root. That question I asked LJ about, that was a square root function. So they convert it back to an exponent. If I was a betting man, they'd probably write that root 5x. Everybody ought to know what 2 cubed is. 8. Any more you can do that thing? Yeah, there is. 8 over 16.
Okay, you can do that?
Yeah, of course you can. Log base 4 and root of 5x over what? 2. Logarithm got a whole lot smaller. Anyways, there's condensing. Let's make one up for y'all to do. Where's my cursor at? Just find you some free space. Oh, nice and easy. 3 things. I showed you how to work with that number, kids. It's really easy. I was just seeing if I could use that as a couple of reference. Right, you're asleep. Although it don't need to be as hard as you let them do. International properties don't make a lot of sense. You got to go. She's smart.
Why me? No.
Just reading that.
I'm not forgetting those.
Chris is wrong.
Anytime he's ever, when nothing said, I got it right, it's usually wrong.
How'd you guys rewrite 4?
Log base 6 of 6 to the power 4.
I'm just gonna write 4 log base 6 of 6 to start. Go back and look at the example that I did earlier. It was a log base 5, wasn't it? I did log base 5 of 5. That makes a 1. Log base 6 of 6 is what? That makes it a logarithm, kids. Now, what Chris was saying is he went ahead and he took his 4 and stuck it up there. Log base 6 of 6 to the 4th. Just do the same thing with any other number you see out front. Where's that 2 belong? On top of the x as an exponent. How about that negative? Sorry, not the negative 2/3. How about the 2/3? You don't actually move the negative symbol. You just move the exponent number. That should have been, your first or second line. Then it's condensing. How did you guys get that log base 6 to 6? That's a 1. That's where it is. When you do your condensing, what two pieces are up top?
6
To the 4th. What else? Squared. What's in the bottom? Y to the 2/3. Now I can put money on a standardized test. They probably wouldn't ask me what 6 to the 4th was. Most standardized tests are actually somewhat designed to be taken on top. But if you want to know what 6 to the 4th is, I guess you push the buttons and do 6 to the 4th, don't you? I have a clue what it is. What is it? 1,726. That sounds familiar. Yeah, 1296. There you go. It says 1296. You want to know it? Push the buttons. That's condensing, which means congratulations, you just finished 7.5. So now you can do your homework on 7.5, and we can start on 7.6. 7.6 is broken into 2 days. Here's part 1. I don't even show you the theorem. Answer that. If 3 to the x is 3 to the 7th, what's x? 9, sure, why not? It's 7. Because if it was 7, wouldn't you have 3 to the 7th equal to 3 to the 7th? So here's the theorem behind that. If you have x, some b, which stands for base, okay, that's a base, set equal to the x, or set with an exponent of x, equal to some base with an exponent of y, then the idea is that those exponents are the same. That's what you just told me. I hope you can see the relationship from what you just told me on that really easy example in the theorem. I hope you can. Huh? We're going to skip the next 2 slides and jump straight to the examples. Get to the actual solving. What we're going to do is we're going to use a little theorem about b to the x being equal to b to the y. And the big deal here is that the bases are the same. If you use our theorem, the left has to be the same number as you have on the right. And here you've got an 80, we're going to do example B first, because example B is way easier than the other 2. In example B, you've got 100 on one side and 1,000 on the other. Both of those share what's called a common base. Both of those are powers of what? 10. Rewrite them as such. 100 is a 10 squared last I checked. So make it a 10 squared. What's already sitting up in the exponential space? Don't get rid of it. Leave it right where it's at. You know the property that's saying you can do that?
The A.
Next to the A.
Yeah.
To the B. Next to the A, B. These multiply exponents together. How do you write 1,000? Thank you. Leave what's there. There. So now you've satisfied that little theorem. You have common bases. They don't matter anymore. As soon as the bases are common, you can just pretend they don't even exist. Gone. So what's true about 2 times 7x plus 1 and 3 times 3x minus 2? They're equal. Just trust the theorem, kids. Property from around 8th grade. It's called the distributive property. What's twice 7x plus 1? 3 times a 3x minus 2 is a 9x minus 6. And then you're still in 8th grade. X is on one side, numbers on the other, 2-step equation. How many x's on the left? 5 of them. What's on the right? What's your x value that makes this true? Negative 8/5. Not a bad theorem. Of course, it gets a little harder when you got fractions. Like C. It gets a little harder when you got fractions. But even A is not that hard. You get more sleep in school than I get at home. It's crazy. You look at example A, which is the next one we'll do. The bases you're given are 81 and 1/9. Focus on the 81 and the 9. What's common base for an 81 and a 9? 9, right? How do you make an 81 with a 9?
9 squared.
9 squared. If you want 9 like that, it might make more sense. What's the understood exponent on that 9? Just move it up. 1/9 is 9 to what power? -1. If you make this right one 81, you better leave the left one 81, right? You could have made both 81s. There you go, kids. That's how hard that is. And there's what you just did. Does the 9s matter anymore? No, all that matters is the exponential space. Because the bases are the same, the exponential space is the same. Twice a 3 minus an x, what's that give you? How about a -1 times a 5x minus 6? Shift your x's left. How many of them are there? 3 of them. You shift your numbers right, what do you get? 0. What's the x value? 0. Because 0 divided by 3 is still 0. You guys get to try C. Look how long it takes.
Yeah, so I like it.
Yes, you should. Did you turn in a take-home test, Jordan? Did you turn in a take-home test? Ouch. You're going to have that for 6 weeks. You might want to do some of that 85.9 Excel. You're in good company. There were 20 some odd kids that didn't turn take-home tests in. It's good because they take forever to grade. It's about 10 minutes for each one of those things. That take-home test was worth 64 points. I gave you 85 points of extra credit in my Excel. It's
So
probably,
for the 60s, you get those to 80.
look at the videos. So, some of the videos say 90 in them. If it says 90, it's a 90. Like there's videos
Like,
attached,
they
right?
like, I know that, but like the description of them.
It'll say like IXL DD3 and in parentheses there'll be a number. Its goal would be a 90. How'd you guys rewrite it for? Through the 2x, I hope. How'd you guys rewrite a half? That's right, Miller, good. Your mama was all worried about you. You're not bad at it. I guess you're just being a mama. Is that what it is? No, that's the hard part. It really is. Next part's the easy stuff. 2x is equal to negative x plus 3. X is 3, that's right. Did you get that one right on your own, Daniel? Good job. You get a check. My wife always told me I should give out stickers. She said she worked hard in high school for stickers. I'm not giving out stickers. But there are a lot of people, mainly females, that would work really hard for stickers. How many of you girls would work harder for stickers? Be honest. You're not a girl. Well, I don't know. Are you?
Can't assume that.
Would you work hard for a sticker? Yeah. I tell you what, you make a B on your next test, I'll put a sticker on it just for you. I guess we're done.
Austin will work hard for a cheeseburger.
Aw,
Monday.
yeah, if you gave away cheeseburgers, Austin would be on the clipboard every week.
Hey, a basics test or like a real test?
Bad real test.
I don't know.
What about the test that we just put?